Okay, in this example, we're going to sketch the circle with this equation showing any intersects with the coordinate axis. So to start with, we're going to take our original equation and we're going to write it in completed square form. So using the x parts, I'm going to have x plus 4 all squared. That will give me the x squared plus 8x. But then I need to subtract 16 from that. I've got y squared minus 14y. That's just going to become y minus 7 all squared, subtract 49. I've got an extra plus 40 that I need, and that equals 0. Now that I've got that, I can collect the constants together and move them over to the other side. So if I've got 40 minus 49, that's minus 9, subtract 16, that gives me minus 25. So when I move it over, it'll be positive 25. Now that I've written my circle equation in completed square form, I can quite easily see what the centre and radius will be. The centre is going to be minus 4, 7. And the radius is going to be the square root of 25, which is 5. So, now that we've got this information, we can start thinking about what it's going to look like on a coordinate grid. So if we have the centre at minus 4, 7, and we moved 5 units to the right, we would go past the y-axis. So the y-axis should cut the circle in 2 places. However, if we started at 7 and moved down by 5, we would find that we don't cross the x-axis. So we've got 2 intercepts on the y-axis and no intercepts on the x-axis, and we need to make sure that that's clear on our sketch. But we can go a little bit further than that, and we can find what those y-intercepts are. So to do that, when it cuts the y-axis, the x-coordinates have to be 0. So we're going to sub x equals 0 into our circle equation. Now you can actually sub it into any version of that you like. I'm going to sub it into the completed square format because that generally will make it easier to solve. So when I put x equals 0 into here, I'm just going to get 4 squared. The other parts contain y, so they'll stay as they are. Now you could solve this by making the quadratic equal to 0, expanding out the bracket and solving it as usual. But because it's already in completed square format, there's a quicker way of doing it. Think about the fact that 4 squared is 16. Subtract that from both sides. We're left with y minus 7 squared on the left-hand side. The right-hand side becomes 9. Now we can square root both sides. So we get y minus 7 equals the square root of 9, which is 3. But don't forget, when you square root both sides, we should have a plus or minus in here. So then we're going to get y equals plus or minus 3 plus 7, which gives us, if we use the plus 1, we get plus 3 plus 7, which is 10. Or if we use minus 3 plus 7, we get 4. So the 2 points where it crosses the y-axis are going to be 0, 4 and 0, 10. Okay, in this example, we're going to sketch the circle with this equation showing any intersections with the coordinate axis. So again, let's complete the square to start off with. We're going to get x minus 10 all squared minus 100. For the y part, we've got y squared minus 12y. That's going to become y minus 6 all squared minus 36. We've got a plus 55, and that equals 0. So let's collect together all our constants. If we do 55 minus 36, that'll give us 19. And then if we subtract 100, that's minus 81. Moving it over to the other side will give us plus 81. That gives us the centre and radius of our circle. The centre is going to be 10, 6. And the radius is the square root of 81, which is 9. Now let's think about what that will look like on the coordinate grid. So if we've got our centre at 10, 6, then if we were to move 9 units in the negative x direction, we'd only get to +1, so we wouldn't cross the y-axis. If we start at the y-coordinate of 6 and move down by 9, we'd get to -3, which is telling us that we are going to cross the x-axis. So in this case, we need to find out those 2 points where it crosses the x-axis. When something crosses the x-axis, the y-coordinate has to be 0. So substituting y equals 0 into our equation for the circle, we're going to get x minus 10 all squared plus minus 6 all squared, which is 36, equals 81. Now, rather than trying to make this equals 0 and trying to solve it, because it's already in completed square form, I can actually use that to my advantage and solve it in a slightly different way. I can subtract 36 from both sides. That gives me x minus 10 all squared equals 45. Then I can square root both sides. It's going to give me plus or minus the square root of 45. Since 45 contains a square number, I'm going to simplify this third to get x minus 10 equals plus or minus 3 root 5. And then I'm going to add 10 to both sides to get x equals 10 plus or minus 3 root 5. This part tells me the points where it's going to cross the x-axis are 10 minus 3 root 5 and 10 plus 3 root 5.